And good morning, everybody. Here are the notes and examples for Algebra 1, Module AA.2, and it's going to be on factoring out a monomial. And what we're going to be factoring out is the greatest common factor that we were studying in the last module, AA.1. And let's just do a quick example of what we mean by factor out a greatest common factor. So, for example, if we had a 20 and maybe a 30, and if we're looking at these two values, if we want to think about what the greatest common factor is, so the greatest common factor, what is the greatest number they both have in common in terms of multiplying? So that would be a 10. So if you factor out a 10, what would you need left behind to multiply it against to make the 20? You would need a 2 right here. Plus, and if you factored out a 10 from the 30, you would need a 3. So if you were to distribute the 10 back in, then you have what you had originally. You would have the 20 and the 30. And notice you're not changing the value of anything. For example, the 20 plus the 30 that we had originally, 20 plus the 30 is equal to 50. And if we look at the factored form where we factored out a 10, if you do what's in parentheses first, you get 2 plus 3, which is 5, and then 5, so this becomes 5. And then 5 times the 10 that you factored out, you get 50. So you're not changing the value of anything, you're just putting it into what we call the factored form. So this would be a factored form, where you factored off a common 10. So this is the factored form. So that was an example. It just had numerical values. You could have algebraic values. For example, if we go back and change the problem a little bit, let's say we had a x to the third and maybe an x squared. So what was the common numerical value that they had between the 20 and the 30? There was a common 10. Let's make a little bit of room here. So the 10 that was common could be factored off, and then we want to look at the variable parts. What do the variables have in common? So notice you have 3 factors of x, x times x times x, and you have 2 factors of x. So what's the largest number of x's they have in common? 2 x's. So they have x times x, that's the common factor. This is what we were doing in the last module. So an x squared was the common factor. And on the first term, you'd have an x left. And on the last term, you would have no x's since you factored them all out. And you can always check your answers for a factoring problem just by remultiplying. So if you do the distributive property, you can check everything. So if you distribute, again, the 10x squared in. So if you do 10x squared times 2x, 10 times 2 gets you the 20. And then the x squared times an x gets you the original x cubed. And then 10x squared times the 3. 10 times the 3 gets you the 30. And then the x squared times x squared would be 30x squared. So you can always check everything by multiplying. I would recommend to always check your factors by multiplying. If you can multiply it back together, then they are probably good factors. So let's go ahead and do a few examples from IXL.com. And here's our first example. They want us to factor out the greatest common factor. So if we look at our two terms, look at the number parts first. What's common between a 3 and a 6? You should be able to factor out a 3 on this. And what's common between the variable parts? So we have a k to the third and a k to the second. So what's the most number of k's they have in common? That's going to be k times k, which is k squared. And then what's left behind that you would have to multiply these against? So if you were to do 3k squared multiplied by something right here, what would need to be there to have the original 3k cubed? You would need another k right there. So we're going to go ahead and say that we're going to need a k right here, because 3k squared times the other k is the 3k cubed that we had, and then we have a minus sign. And then what would have to be right here to have the original term? So we need to get 6k to the second, so we're going to need a 2 there. And again, you can check it by multiplying. 3k squared, 3 times the 2 gets you the 6, and then times the k squared gets you the k squared. So if you distribute everything back together, you should have your original form. So this is what they call the factored form. And if you multiply it together, you should have the original statement. So 3k squared parentheses k minus 2. And let's go ahead and look at another example. So this one, again, look at the number parts first. So what's common between a 2 and a 4? So you could factor a 2 off. And what's common for the variables? We have a d to the third and a d. So the largest number of d's they have in common is 1d. And what would have to be left behind? So you would need a d squared, because 2d times d to the second would be the first term, 2d to the third, minus, and what would we need on the second term? You would need a 2, because 2d times the 2 should get you 4d. So that's going to be your factored form. If you are struggling, you can always break everything down into their prime factors, like what we were doing on module AA.1. So you could take the first term and say we have a 2 d times d times d, minus, and then the 4 is 2 times 2 times d. And you don't necessarily need to write this down like this unless you're struggling. Typically, this is what most people are doing in their head. So if we look at the first term, what do we have common? We have a 2 in common, and we have a 2 in common. And if we look at the d's, how many d's do we have in common? We have a single d on this one and a single d on this one. So what's the greatest common value that can come out? You can take out a 2d. And then what's left behind in the parentheses is all the stuff that wasn't common. So on the first term, it was a d squared minus, and then on the second term, it was a 2 that was left behind. So basically all the common stuff comes out, all the uncommon stuff stays in the parentheses. And looking at this next one, if you look at the number parts, a 2 and a 3, they don't have a common factor other than 1, so we have no numerical common values. But if we look at the v's, you have 3 v's and 1 v, so 1 v is common. So 2v squared minus 3. And again, just check it real quick by remultiplying. V times the 2v squared should get you the 2v cubed, minus v times the 3 should get you 3v. So this checks out. So this is going to be your factored form, and that's what you're going to put into the answer box. And here's another one. Looking at the numbers, what's common between a 2 and a 6? So they have a greatest common factor of 2. What's common between the variables? You have b squared and b, so you have a common b. And what's left behind on the first term? 2b would have to get multiplied by a b to make 2b squared, plus 3 times the 2b would make the 6b. And again, check it real quick by multiplying. So that should be our 2b squared and that is our 6b. So this would be the factored form. That's your answer. You want to put that into the answer box. And another one, look at the numerical values, what's common between a 14 and a 4. So we know they have a 2 in common. And what's common between the variables? We have a g to the second power and a g to the third power, so g times g to the second power is common. And what do you need on the first term? You would need a 7, because 2 times the 7 makes the 14, and you need another g, because g squared times g makes g to the third, plus you're going to need a 2 to get the 4, and then g squared, all of that came out. And as always, check it by remultiplying. So that's our 14g to the third plus 4g squared. So there is your factored form. That is going to go into the answer box. And here's another one. As you work your way through the modules, the idea kind of stays the same. The numbers and the size of the variables kind of gets bigger, but it's still all the same idea. So if we look at 28 and 35, what's a common value that they have in common in terms of a greatest common factor? So we know 7 times 4 is 28, and 7 times 5 is 35, so they have a 7 in common. And z to the 10th and z to the 9th, so they have, or sorry, not z, s to the 10th, s to the 9th, so they have a s to the 9th in common. And then, again, what do we need here to reproduce the 28s to the 10th? You're going to need a 4 to make the 28, and another s to make the s to the 10th. So we will need a 4, because 4 times 7 is 28, and you'll need an s, because s times s to the 9th is going to make the s to the 10th, plus we're going to need a 5 to make the 35, and then s to the 9th, all that was pulled out. So that's going to be your factored form. And again, just double check it by remultiplying. So 7 times 4 is 28. S to the 9th times another s is s to the 10th. Plus 7 times 5 is the 35. And then you have the s to the 9th. So that checks out. So again, this is the answer. And here's the last one. So this one's a little different. It has 3 terms and more variables, but again, idea stays the same. Look at the number parts and see what is common between a 10, a 13, and a 9. So we know a 10 is a 2 times 5. We know a 13 is a 1 and a 13. It doesn't really break down any further. It's a prime number. And we know a 9 is a 3 and a 3. So they really don't have any numerical values in common except for a factor of 1. So we can't take out any common numerical values. And then if we look at the variable parts, the p's, you have a p to the 7th, and you have a p. So these two terms have one p in common. But notice this term doesn't have any p's, so there is no common p. And then if you look at the q's, you have a q to the 6th and a q to the 7th. So the first two terms would have 6 q's in common, q to the 6th. But again, if you look at the last term, there are no q's. So you don't have any numerical parts in common, you don't have any variable parts in common, you don't have any p's or q's in common, so really there is no common factor. So there's no common factor. no greatest common factor that could be factored out. So notice the directions. If there is no greatest common factor and all you could factor out is a 1, then just retype the original expression. So this one cannot be factored. So cannot be factored. So you're just going to retype what they have right here into the answer box, indicating that it cannot be factored. And that is it. That is your notes and your examples for IXL module AA.2 in the Algebra 1 section.